All right, class, in today's lesson, we're going to talk about law of sines, which is section 6.1, part 2. Our objective is to use the law of sines to solve oblique triangles, which is side-side angle. This is just more information that you may want to take a look at, trying to figure out how do you know how many solutions that you'll have for a triangle and things of that nature. The ones that you want to take a really close look at are these two that are kind of in the middle. Point them out. So like this one here. Okay, it erased itself. It's still going to erase itself, so ignore that. I'm just trying to say this one. Okay, so this triangle actually gets two different triangles. It can either be the smaller triangle on the inner, or it could be the actual larger triangle on the outer. And it's because A can either be, well, it has two situations. A is between H and B. So in other words, A is less than B. And when that happens, you get two solutions. So if A is less than B, it either has no solutions, because like in this case, if A is less than B, it has no solution, or it could have two solutions. And so when those type of situations happen, you'd actually have to check it. Also, this H that we're looking at, the H is actually the height of your triangle. And so to find H is right here. You would do B times the sine of A to figure out what your H is. A lot of times we skip this step. It actually is a pretty crucial step to try and figure out if you're doing it correctly, but just a heads up. So essentially, I'm showing you this to say this rule here. If A is greater than B, then you only have one solution. If A is less than B, then you either have one solution, either no solution, oh my goodness, either no solution or two solutions. Okay. So in example 3, we're going to do a single solution case. This is a side-side angle type situation. And again, I know that this one is going to have one solution because A is greater than B. And again, when A is greater than B, it's one solution. Okay. All right, so for this triangle, again, we're still using what we've been told. So we need to find the remaining sides and triangles. I typically like to draw mine out just so I can see everything and see what I'm missing. It's a little bit easier for me. So I just draw some random oblique triangle. I put sides on it. So I'm going to make this A. I'm going to make that B. I'm going to make that C. That means that this is little a, this is little b, and this is little c. Okay, putting the information on there then, that means that A is 22 inches. That means that B is 12 inches. And again, of course, this is not drawn to scale, right? Because obviously it'd be flipped around. And then A is 42 degrees. But again, I'm just doing this so that I can have a visual to see what I'm missing. Okay, so obviously the main information that was given to you, a full alphabet group that was given to you is the A, right? So we have side A, and then I have angle A given to me. So everything that I'm going to use is going to be against it. Okay, so if I have A over sine A, which would be 22 over sine of 42, okay, then I am going to try to find B's information. So B's information will be 12 over sine B. Okay, so this is the first time that I'm not actually just finding an angle finding a side, which is a lot easier than finding an angle, because sometimes we kind of get lost in it. So the math for this to find sine B then would be 12 times sine of 42, right? 12 times sine of 42, and then we're going to divide by 22. So again, sine B is 12 times sine of 42 over 22, okay? Now that gives you approximately 0.3648, okay? And so if I actually, and that's just the ratio for that sine, right? But if I want to find the actual angle for B, that means that I have to use the inverse function, right? So, and my pen is not letting me write, but sine, the inverse of sine of 0.36498 is about 21.4 degrees. Okay, so you got B. If you, so that's this, so this is now 21.4. So if you got 21.4 degrees, then I can also find C, angle C. I'm going to switch colors because it's getting a little confusing. So if I find angle C, C would be 180 minus the two angles that I found. So minus the 42 degrees that I was given and minus the 21.4 degrees, 1.4 degrees that I just found. And that would give me 116.6 degrees. So this here is 116.6. And again, now I can finally find side C, because again, I'm going to use what I was originally given. So that's that 22 sine, or 22 over sine of 42. In other words, all of A. And it's equal to C over sine of 116.6. Now this one I don't have to go back and do like the inverse, right? Because with sides, they're a lot easier to find than angles. So if I do that math, side C, if it'll let me draw it, will be equal to 29.4 inches. And we are done with this problem. Let's look at the next one. Okay, so on this one, it says, show that there is no triangle for which A equals 15, B equals 25, and capital A is 85 degrees. So the full information that we were given is A and angle A, right? So we would put 15 over sine of 85, which, by the way, this is one of those cases where A is less than B, right? A is less than B. And so when A is less than B, you either get two solutions or you get no solutions. And so, in other words, they're saying, okay, set it up just to see if it's going to give you the no solution setup, okay? So 15 over sine of 85 equals 25 over sine of B. Though we don't know what B is just yet, that would be what we would do to find it. So we would cross multiply. And so you would have 25 sine of 85 divided by 15 would give you sine of B. Essentially what that would give you then is about 1.66. Now you should be able to look at that and know that that's not going to work, because a sine curve, the range only goes from -1 to +1, so 1.66 is outside of it. But in case you don't know that, you can always use the inverse of sine, which by the time you get to a test, sometimes we just want to double check anyway, right? So the inverse of 1.66, oh my goodness, come on, pen. 1.66 should give you angle B. And again, it does not work. It'll say not possible and all those other things. And again, it's because 1.66. It's because 1.66 is greater than 1. Okay, so it will not work. All right, let's take a look at our last problem. So this one is a 2-solution case. Again, A is less than B in this situation, and we could test it, but I'm going to tell you now that it is going to work with 2 solutions. So if we set this up, the true alphabetical form that was given to you is the A information, right? So everything is always going to be set against 12 over sine of 20.5 degrees. So this is 12 over sine of 20.5 equal to, let's go ahead and find B's information. So this is going to be 31 over sine B. Okay. Sine B then, in that case, right, if I cross multiply, will be sine B equal to 31 sine, again, I'm cross multiplying sine of 20.5 over 12. Okay, if I do that math, I would get approximately 0.9047. So to find B then, and remember you get 2 actual angles for B. I'm going to get B sub 1, so that's my first one. If I do the inverse of sine of this angle 0.9047, that will give me, for my first angle, 64.78 degrees. That's my first angle. Okay, but then like I said, there are 2 of them, so to find the second B angle, I would do 180 minus that answer. So 180 minus 64.78 degrees. And you get 115.22 degrees. Okay. So for the B1 information, so we found everything with A. I'm going to split these into 2 different sections because now it's going to get messy. For B1's information, and as a reminder, B sub 1 is 64.78 degrees. Mind you, we still have little b as 31. We still have, in other words, you still have all this information as the same. It's all the same. Okay, but to finish finding the C information on it, you would do, to find angle C, you'd have to do 180 minus angle A, which is 20.5 degrees, minus the 64.78 degrees. And that gives you 94.72 degrees. Okay, and then if I have that, then I also need to find side C, which again, you want to count everything against the alphabet that you were given, the full alphabet that you were given in the beginning, which is little a and big A. So it's going to be 12. So 12 over sine of 20.5 equal to little c, which is a we don't know, over sine of 94.72 degrees. Okay. That will then give us that little c, and I have to call that C1. Little c1 is going to be equal to 34.15 meters. So 34.15 meters. All right. So that's for C1's information. Now we have to do the same thing for C2, and I'm almost out of space. So let's try and fit that in here. Now remember, B2 is 115. Okay. It is 115.22 degrees. So I need to find C2. So C2 would be 180 minus the 20.5 degrees from A minus the 115.22 degrees. Okay, that will give you 44.28 degrees. 44.28 degrees. Okay, so if you have that, now I can set up my other triangle. My last proportion. Again, reverting back to A's information that we're given in the beginning, that's 12 over sine of 20.5 equal to little c2, which we don't know yet, little c2 over sine of 44.28 degrees. Okay, that means then that little c2 would equal 23.92 meters. Whew. All right, we are done. If you have any questions, again, please come see me for tutoring.